A Unix system is made up sort of three layers, if you like. The central layer, the kernel, is the thing that controls the resources of the machine. Then wrapped around that, at least conceptually, is something called the shell, which is the interface between most users and the kernel part. It sits there and waits for you to type commands at it, and then it interprets them. And then around that is sort of yet another layer are useful programs, things like editors and compilers for programming languages and document formatting programs, and programs that you write yourself. And what you can do is to think of these Unix system programs basically as, in some sense, the building blocks with which you can create things. And the thing that distinguishes Unix system from many other systems is the degree to which those building blocks can be glued together in a variety of different ways, not just obvious ways, but in many cases very unobvious ways, to get different jobs done. The system is very flexible in that respect. I think the notion of pipelining is the fundamental contribution. If the system is, you can take a bunch of programs, two or more programs, and stick them together end to end so that the data simply flows from the one on the left to the one on the right. And the system itself looks after all of the connections, all of the synchronization, making sure that the data goes from the one into the other. The programs themselves don't know anything about the connection. As far as they're concerned, they're just talking to the terminal. Now let me give you an example of how this works in practice. The system, as I mentioned, is used a lot for document preparation kinds of things. Programs for helping you type letters or produce technical papers or write books. In all of those things, of course, people, when they're typing at the machine, make spelling mistakes. So let's see how we could use some of these building block notions in practice to help you develop a program for finding spelling mistakes. Suppose I take a sentence. This is a sentence which is in a paper that John Massey and I wrote some years ago now. If you look at it carefully, you'll see that there are actually a couple of spelling mistakes in there. Now, suppose that we wanted to find the spelling mistakes using a machine. How would we do that? Well, basically what we would do, the simplest thing I can think of, is to split the sentence there into words, individual words, and then compare the words against a dictionary. And every time we find a word which is in that sentence but not in a dictionary, it's at least a plausible contender for being a spelling mistake. Now, how do we do that? What I want to show is that you can do that using just existing Unix programs, just gluing them together to get the job done. Suppose that we say, first we'll take a program called MakeWords, and we'll run that on the sentence. Now what that does is to break the thing up into one word per line. Now I'll take the output and I'll pipe it into another program which will simply convert it into lowercase. The reason I want to convert it into lowercase is that my dictionary doesn't have any capitalizations, and so words like Bell and Unix, which are capitalized here, would show up as spelling mistakes unless I did this. Now, the next thing that I want to do, my dictionary is in fact sorted in alphabetical order as dictionaries are, and so it's a lot easier for me to compare the words of my document to the words in the dictionary if they're sorted, so I'm going to run them into sort. And finally, if you look at it carefully, it doesn't show up very easily here, but there is a duplicate word there. Systems appears twice, and in a real document, words like THE would show up many times, so we'd like to get rid of duplicates. So let's throw that through another program called Unique. So what we've got so far is we've got the words of my document, in this case the sentence, one word per line, in lowercase, neatly sorted, and all of the duplicate words thrown away, so there's only one word, one instance of each different word. And then what I'm going to do is run it into one last program called Mismatch, which will simply print all of the words that came down this pipeline and print out the ones that were in the document that weren't in the dictionary. So what we have here is 5 separate programs cooperating to do this job, and in one giant pipeline. Now if you look at the list that came out, you'll see that indeed we got laboratories and provide, which were our 2 spelling mistakes. And of course we got 2 other words as well, and this tells you not only what's good about the approach, but also what's bad about it. Time sharing is not a spelling mistake, but it's a perfectly fine example of technical jargon, the sort of thing that means something to everybody in the computer business. It means nothing whatsoever to people who are not computer types. And the word Unix is a fine example of something that's not going to be found in a normal dictionary. So, what do? First, we take the misspelled words and we go back to the original document and we correct them so we don't have any spelling mistakes. Secondly, we take the words that, like timesharing and Unix, that are not spelling mistakes but which showed up here, and we put them back into our dictionary so that the next time somebody has a document that contains Unix or timesharing, they don't show up as spelling mistakes. So we've not only done our own job, but we've improved the tool that we're using in the process. So you notice that I did that whole job without writing any programs at all. The whole thing is cobbled together out of programs that already existed, and all I did was to use the fact that the system provides this mechanism of the pipeline so that I can take programs and stick them together one after another to get my job done. And I think this is one of the reasons why the system's so productive, that there's a large collection of things that people have already built that we use, and as we build our new things, then they become part of the repertoire of things that people subsequently can build on.